Chapter 6 is going to be about a thing called rational expressions and the equations and the word problems that are related to that. The basic definition of a rational expression is that it means a fraction that has variables in it. Well, that's not quite right. It's not so much any variable showing up anywhere in the fraction. It specifically means a polynomial over a polynomial. So you can think of this as learning about polynomials and then taking it one more step. So you already know what polynomials are, you know how to plug into them, you know how to factor them, you know a lot of things about polynomials. Now we take it one extra step by writing fractions using polynomials. So that's the basic definition. Here's an example. 2x squared plus 5x minus 3, that's a polynomial. X squared minus 9x plus 20, that's also a polynomial. And if you're learning a new type of expression like this, one of the most rudimentary basic things that you could possibly do to try to understand it is to just try plugging in things. Like let's try plugging in x equals -2 and make sure we understand what this expression is telling us to do. It means every place where there's an x, you replace the x with the number 2, and then you do all the arithmetic that you're supposed to do based on what you see there in the problem. So in the numerator there, we're going to have 2 squared is 4, times 2 is 8, 5 times 2 is 10, minus 3. Down here we're going to have 4, minus 18 plus 20. So let's see, 18 minus 3 is 15 in the numerator. Negative 14 plus 26 in the denominator, and oh wait a sec, I can cancel 3's and I get 5 over 2. So if you have a fraction that has a polynomial numerator and a polynomial denominator, and you plug a number into it, you shouldn't be too surprised that your answer in the end comes out to be a fraction as well. Let's practice again. Let's try plugging in 5. So we get 2 times 5 squared plus 5 times 5 plus 3 over 5 squared minus 9 times 5 plus 20. So 25 times 2 is 50 plus 25 plus 3 over 25 minus 45 plus 20. So that's 78. Wait a second, I just realized I lost a minus sign right about there. Not 78, 72. Oh, wait a sec. There's something much worse than that. I got one little minus sign wrong, but look what the denominator's coming out to be. 0. That, of course, is a huge problem. And we didn't have that problem with polynomials, because polynomials you didn't divide by anything, but with rational expressions, since there's a denominator, now we have to remember that dividing by 0 is impossible. It's undefined. So that means that when we're working with these problems, one of the first issues is you're going to have a warning label on them. There's a thing called the domain of a rational expression that you're going to be asked to figure out. And this division by 0 thing is so common and so well understood that it even is used to make internet memes. You know you can't divide by 0. Everybody thinks it's kind of funny that dividing by 0 is impossible. Don't let yourself make that mistake. So here's the concept. This is the potential danger. The thing that we want to avoid is that this expression could come out to be 0. If x squared minus 9x plus 20 comes out to be 0, that's a bad thing. Now, that's also not just a bad thing, it's also an equation, and it's a relatively simple equation to solve. You just factor it, because it's already equal to 0, and you get x equals 5 and x equals 4. But remember, x equals 5 and x equals 4 are not good things, those are bad things. So the lesson here, the message that you want to convey is don't plug in 5 or 4, because bad things happen. And the way we say that mathematically is we say the domain is x not equal to 5 or 4. That's the mathematical way of saying you can plug anything in as long as it's not 5 and as long as it's not 4. The domain is everything except 5 and 4. So that's the first issue with these things. You've got to have a warning label on them as sort of a preliminary before you try to do anything else. The second issue that you have with these things is because they're fractions, just like any other fraction, you have to reduce them. So if you had a fraction 3x minus 12 over 3x plus 21, you're going to have to do some cancellation. But let me warn you, for some reason, people start to do really crazy kinds of cancellation here, where they cancel the 3's that are in front of the x's. And I want to remind you that you actually already know that that's not legal. Like for example, imagine you were in elementary school, and one of your friends was supposed to reduce the fraction 5 over 10, and what they did was they wrote it as 1 plus 4 and 6 plus 4, and they canceled the 4's, and they said the answer was 1/6. Wouldn't you tell them they were wrong? That's not allowed. That's not legal. So if you tried to cancel the 3x's here, that's just as wrong as canceling the 4's and getting 1/6 in that example. So you know this isn't legal. Don't forget what you already know. So unfortunately, we cannot cancel the 3x's. But there's something kind of similar we could do. Here, where we had this 5 over 10, if you wrote it as a multiplication instead of a division, or instead of a sum, multiplication, you can cancel the 5's and get a half, and that works just fine. So really the trick is write it as a multiplication. In other words, factor out the 3 from the top, factor out the 3 from the bottom, and you can cancel those 3's because that's multiplication. Canceling with multiplication is allowed. Canceling with addition, or for that matter subtraction, not allowed. So the real trick here is that sometimes the factoring will be tough. I mean, that's what it really basically boils down to, is step 1, factor, step 2, cancel. And step 2 will be easy once step 1 is finished, because the cancellation is really obvious. It's not obvious until you factor, but once you factor, then it's obvious. So here, factor the top, and you might want to pause the video and try factoring it yourself, and then press play, see if I get the same thing. Alright, the top factors into 2x minus 3 times x plus 4. Don't forget to check. You should FOIL that out. You're going to get an 8x minus a 3x makes the 5x in the middle. 2x times x is 2x squared in the beginning. 4 times negative 3 is negative 12 in the end. Denominator factors x minus 5 times x plus 4. And you'll notice once all the factoring is done, the canceling is obvious. There's a common factor in the top and bottom of x plus 4, so that cancels out. Leaves us with the answer of 2x minus 3 over x minus 5. And then there's a third issue. One last little thing, and this is a fairly small thing, but it does cause some headaches down the road a little bit. So I want to make sure we clear this up in the beginning. And it has to do with the rule about canceling opposites. You know with numbers that when you have opposites, like 3 and negative 3, or negative 12 and 12, that when you cancel those, your result is negative 1. Well, the same thing is true with polynomials. If you have opposites, like here, this is the opposite of that. Then, when you cancel, you're going to get negative 1. You don't have to factor if you don't want to. Factoring would work, but the answer is too simple. It obviously gives you negative 1. But the trick is that sometimes opposites are a little harder to identify. Like here, this and this, these are opposites. And just to make sure there's a clear rule for this, the rule is all the signs have to be reversed. And it doesn't matter whether the top is positive or the top is negative, or the bottom is positive or the bottom is negative, as long as they're opposites. All signs have to be opposite. And in that case they are, so you can cancel, you would get -1. The place where people tend to go wrong is with problems like this. One of these has actual opposites and cancels to -1, and the other one isn't really opposites. So take a look at the right-hand one, w minus 3 over w plus 3. These are not actually opposites. For the 3's, the signs are opposite, but if you look at the w, the signs are the same. So overall, because the w's match, you cannot cancel in that fraction. The answer to that reduced fraction is w minus 3 over w plus 3. There is no simpler way of writing it. Whereas the one on the left, it almost looks like the top and bottom are the same, except look here and here, and look here and here. The order is different in the bottom than it is in the top, but that's not the only difference. The 3 in the bottom is positive, in the top it's negative. The w in the top is positive, in the bottom it's negative. So there, both the w's and the 3's are opposites in the top and bottom. That one does cancel to -1. So it seems like an easy idea at first, canceling and producing -1, but it's not necessarily as obvious as it appears at first.